Good morning. Now the subject is about micro and optical engineering. In that we are going to see about the topic is circulator. In simple term, circulator is a device in which RF signal travel from one part or one port to the next in one direction. That is either clockwise or anti-clockwise. There are two types of circulator based on the number of ports. That is 3-port circulator and 4-port circulators. The microcirculator is a multi-port device in which power is circulated from nth port to n plus 1th port only in one direction. A 4-port circulator is most commonly used. The following figure shows a 4-port circulator schematic, and the circulator is not a reciprocal component. All the 4 ports are matched and transmission of power takes place in cyclic order only. An ideal circulator is perfectly lossless. The circulator is a device in which microwave and radio frequency signals entering any port are passed on to the next portion is rotation only. A port in this context is the point where an external waveguide or transmission lane is connected to the device. For a 3-port circulator, suppose signal is applied to port 1, the output is observed at port 2 and port 3 remain completely isolated. This is one of the main application of a circulator. If the signal is applied to port 2, then the output is observed at port 3 and port 1 remain completely isolated. So the scattering matrix of an ideal circulator is, what is 4-port circulator? Just see about the diagrammatic representation. 1, 2, 3, 4 has been represented. Now the circulation has been take place by this scattering matrix parameter and its schematic diagram. A 4-port circulator can be made using two magic T also and one non-reciprocal 180-degree phase shifter. It can also be made using two 3 dB direction coupler with side holes and two non-reciprocal phase shifters. Power entering port 1 travels along the magnetized ferrite. The direction of electric field vector gets rotated by 45 degrees. Therefore, power enter at port 1 appear at port 2. The power cannot be coupled to port 4 because port 2 and port 4 are 90 degrees out of phase. Similarly, port 3 is coupled to port 4 and port 4 to port 1. See the diagrammatic representation of port 1 and port 2, port 3 and port 4 has been shown out with the ferrite components where the 180-degree phase shift and 45-degree phase shift and 90-degree phase shift has been occurred by these approaches. What is a 3-port circulator and 4-port circulator by the magic T's? By the 4-port circulator, we can see how the phase shift has been occurred and phase shift has been used out in the magic T for a 4-port circulator. And 3-port circulator has been shown in the diagram where the ferrite post the electric energy has been transferred by its magnetic field also shown out. So this is about the 4-port and 3-port circulators has been shown how the energy has been transferred. By the 180-degree phase shift mean it will be transferred the signal is opposite of direction, whereas 45-degree means it's the phase shift of 45-degree only, whereas 90-degree means it will shift out the phase shift by 90-degree only, whereas 180-degree it will totally comprise the signal into a negative positive into a negative signal, negative into a positive signals. The above diagram represents 3-port RF circulator. The signal that is to be transmitted travel from one port to two port and signal received at antenna travels from port 2 to port 3 as shown. S is equal to some diametric representation as scattering parameter as represented. In simple term, a 3-port circulator is formed with 120-degree H-plane waveguide or by using strip-line symmetrical Y junction. A 3-port circulator is an asymmetrical Y-type junction of 3 identical waveguides with an axially magnetized ferrite post placed at the center. The ferrite post is magnetized by a static magnetic field along the axis. It provides the necessary non-reciprocal property. The junction can be matched by placing a suitable tuning element in each arm. It is an essential component used to isolate the input and output in a negative resistance amplifier. The 3-port organ is used to compel a transmitter to various receivers. So So this is about the difference of 3-port and 4-port circulators. The 3-port circulator is formed by 120-degree each of each parameter waveguides by using simple strip-line symmetrical Y junction, whereas 4-port circle can be made by two magic T's and one non-reciprocal degree phase shifter. And the scattering matrix is a lossless perfect match non-reciprocal 3-port circle is shown in below as S is equal to S00, S13, S21, 00, S32 and 0, whereas S matrix for a 4-port is about lossless perfectly matched and non-reciprocal 4-port circular is shown by 0001, 1000001000010 as represented out. So this thing will be the difference of 3-port and 4-port circulators. Any queries? Thank you.